Myself, Rajendra Karai. My qualification is MSc Chemistry BF and experience is of 28 years. Now today we are going to discuss about the topic experimental measurement of rate of a chemical reaction. Now here rate of a chemical reaction can be measured by monitoring the concentration of any one of the reactant or product as a function of time. Now here the measurable commonly measurable properties like change in volume, change in pressure, change in electrical and thermal conductivity, change in optical rotation, change in color, pH or refractive index, related to concentration of species taking part in the chemical reaction is selected. And change in this property is measured as a function of time. Now, here write down first calculation of average rate of a chemical reaction. Now here this point is in this only for CBSE 12 NEET and JEE. Now here average rate of a chemical reaction can be measured by plotting a graph between the concentration of any one of the reactants or products as a function of time. That means here draw the graph now here I don't time in minute, that is 0, 10, 20, 30, 40, 50, 60, 70. And here I put concentration in mole per liter, that is 0.02, 0.04, 0.06, 0.08, 0.10, and here 0.12. Now here draw the graph. This time is T1 and concentration corresponding to this time is X1. This time is T2 and concentration corresponding to this time is X2. That means here average rate of chemical reaction can be measured by noting the concentration of reactants at two different times. That is T1 and T2. That means here X1 and X2 are the concentrations of reactants at time T1 and T2 respectively. Now here R average del T of concentration of R minus del T of concentration of R, meaning is that minus X2 minus X1 upon T2 minus T1. Now this is regarding about the calculation of average rate of reaction by using the graph. That means here I also write down R average is equal to minus del T of concentration of R, and which is equal to minus X2 minus X1 upon T2 minus T1. Then write down second. Calculation of instantaneous rate of a chemical reaction. Now here instantaneous rate of a chemical reaction can be measured by plotting a graph between the concentration of any one of the reactants or products as a function of time. That means here draw the graph. Here write down time in minute 0, 10, 20, 30, 40, 50, 60, 70. And here write down concentration of reactant in mole per liter. That is 0.02, 0.04, 0.06, 0.08, 0.10, and here 0.12. You will get the graph like this. Now here let us consider this point P and draw the tangent to the curve at this point. That means like this. Now let us consider this point P and draw the tangent to the curve at this point like this. Now this point correspond to 20 minutes. Now extend this tangent along y-axis as well as along x-axis. This point is called as A and this point is called as B. Here write down R instantaneous is equal to minus dr upon dt, and which is equal to minus slope. That means here instantaneous rate of a chemical reaction can be measured by drawing a tangent to the curve at a point P corresponding to the given time and extended to intersect both the axes. That means this is your graph. You can consider this point P correspond to the time 20 minutes. Now draw the tangent to this curve at point P. This is your tangent. Now extend this tangent to intersect both the axes, that is y-axis and x-axis. Now here this tangent intersect the y-axis at point A and this tangent intersect the x-axis at point B. Now here slope of the tangent gives the instantaneous rate of a chemical reaction at that time. Now here distance OA the distance OA along the ordinates, that means along y-axis, gives the change in concentration delta x, while the distance OB along the axis are, that means x-axis gives the change in time delta t. Now keep in mind, most important point is that y-axis is called as ordinates, while the x-axis is called as abscissa. Now here write down R instantaneous is equal to d dt of concentration of R, and which is equal to minus slope of the tangent. That means here distance OA upon distance OB, that means delta x upon delta t. Now in this case, concentration of reactant goes on decreases with increase in time. That means this curve is in the downward direction, and here you will get the slope of tangent, and that slope of tangent is negative. That means value of this slope or this slope is negative. That means negative into negative positive, and therefore R instantaneous is also positive. Now third, calculation of average rate of a chemical reaction. Only for CBSE 12 NEET and JEE. Now, first point is that calculation of average rate of reaction using concentration of reactant. Second topic, calculation of instantaneous rate of reaction using concentration of reactant. Now this calculation of average rate of reaction using concentration of product, that means here average rate of a chemical reaction can be measured by plotting a graph between the concentration of any one of the product as a function of time. That means here write down time in minute 0, 10, 20, 30, 40, 50, 60, 70. Here write down concentration of product in mole per liter. Now let us observe, during any chemical reaction, reactants are converted into product. That means reactants are disappear. That is concentration of reactant it decreases, while the products are appear. That means the concentration of product goes on increases. In this case, the concentration of product goes on increases with increasing time. So the graph moves in upward direction like this. Now here you can consider again time 10 minutes, that is T1, and concentration corresponding to T1 is called as X1. Here considered time T2 and concentration corresponding to the time is x2. Here write down 0.02, 0.04, 0.06, 0.08, 0.10, and here 0.12. That means here R average is equal to plus del T of concentration of P, and which is equal to x2 minus x1 upon T2 minus T1. That means here average rate of a chemical reaction can be measured by noting the concentration of product at two different times. Suppose here x1 and x2 are the concentration of product at time t1 and t2 respectively. That means here R average is equal to plus del T of concentration of P, that means here plus x2 minus x1 upon T2 minus T1. That is, this is regarding about the calculation of average rate of reaction by knowing the concentration of product. Then write down 4. Calculation of instantaneous rate of a chemical reaction Here also write down only for CBSE 12 NEET and JEE. Now here instantaneous, that means by using the concentration of product. Here instantaneous rate of a chemical reaction can be measured by plotting a graph between concentration of product, concentration of any one of the products as a function of time. That means here write down time in minute 0, 10, 20, 30, 40, 50, 60, 70. Here I don't concentration of product in mole per liter 0.02, 0.04, 0.06, 0.08, 0.10 and here 0.12. Now here draw the graph like this. That means you have draw the tangent to this graph at time suppose 35. Suppose this is point P. Now we are this is A, this is B, and here let us take O. That means here R instantaneous is equal to d dt of concentration of P and which is equal to slope. Now slope of this line is positive. Now here the instantaneous rate of reaction instantaneous rate of a chemical reaction can be measured by drawing tangent to the curve at a point P corresponding to the given time. That means here and extended to intersect both the axes. Now here slope of the tangent gives the instantaneous rate of a chemical reaction at that time. Now the distance OA along the ordinate that means along y-axis gives the change in concentration that is delta x, and the distance will be along the abscissa, that means along x-axis gives the change in time delta t. That means here R instantaneous is equal to d dt of concentration of P, that is slope of the tangent. That means d of OA upon d of OB, and which is equal to delta X upon delta T. Now this is regarding about the experimental measurement of rate of a chemical reaction. That means average rate of chemical reaction as well as instantaneous rate of chemical reaction in terms of concentration of reactant as well as concentration of product. Now remaining part of this unit will be discussed in the next lecture.